Hi students. Okay, today we are learning the topic is to finding the solution of non-homogeneous equation f of d into y is equal to q of x. That is higher order ordinary differential equation with the constant coefficients. In the previous lecture we find out the solution of the homogeneous equation and also non-homogeneous equation. Also one method is completed, that is general method. So that is 1 by f of d can be expressed into partial fractions. So that method is completed. Next one is some special cases when the depend on the q of x. So q of x is a function of x given some types of function of x only. So using that function q of x, you have to finding the particular integral. So that is this is the shortcut methods that depend on the function of q of x. Okay, in this one the first to type 1, that is case 1, when the given q of x is equal to e power ax, where a is a constant, then how to finding yp in this case. Okay, see that here. So solution same only, non-homogeneous solution is y is equal to yc plus yp. Yc is a complementary function, the same procedure. Next now discussing here finding yp. Okay, see the procedure here. When given equation f of d into y is equal to q of x, where q of x is equal to e power x and f of d is equal to polynomial, nth degree polynomial. So therefore particular integral of equation 1 is yp is equal to 1 by f of d into q of x, where q of x is equal to e power ax. A is any constant. So now in this f of d replacing d by a. So directly in the polynomial f of d, first of all f of d polynomial can be write in the factorization only. Write the product of the all factors after replacing d by a. A is the given a constant, d place lo a replace చేయండి, that is equal to here 1 by f of a into e power ax. So this is the required particular integral of given equation. So after replacing d by a must be the condition is f of a is not equal to 0 only after replacing d by a. So that is a yp. In case after replacing d by a we getting the 0, when f of a is 0, so this is another case. If f of a is equal to 0, that means d minus a is a factor of f of d. Then a is the root of the polynomial f of d. Then how many times repeated, that is the important. So now assumption is a is a root repeated k times only. Now assumption only for f of a is equal to 0. Then the particular integral is x power k by k factorial. In case f of a is equal to 0 and a is a repeated k times, the particular integral is equal to x power k by k factorial into 1 by phi of a. 1 by phi is a non-zero factor. This is a non-zero factor, that is phi of a is not equal to 0. Okay, this is the particular integral finding when q of x is equal to e power ax. Okay, see the example here. See that first one, solve d square y by dx square plus 4 into dy by dx plus 3y is equal to e power x. So first try the operator form is, so d square plus 4d plus 3 into y is equal to e power x. Okay, first of all finding the complementary function. Okay, na, where f of d is equal to, take the auxiliary equation, this is f of d and q of x is equal to e power x. So auxiliary equation m square plus 4m plus 3 is equal to 0, finding the roots. So m plus 1 into m plus 3 is equal to 0, m is equal to minus 1 comma minus 3. This is the roots. So that is equal to here, complementary function is equal, this is real and distinct roots here. C1 into e power minus x plus C2 into e power minus 3x. So now finding the yp, particular integral, yp is equal to 1 by f of d into q of x. So 1 by f of d is equal to polynomial d square plus 4d plus 3 into e power x. Q of x is equal to here e power x here. So now here first of all take the product of the factor, that is equal to here 1 by d plus 1 into d plus 3. So here a is equal to formula 1, e power ax kada, a is equal to 1. So in this one replacing d by 1. So that is equal to replacing d by 1. So that is equal to here 1 by 1 plus 1 into 1 plus 3 into e power x. That is equal to 1 by 8 into e power x. This is the required particular integral when q of x is equal to e power x. Therefore general solution is yc plus yp. That is equal to adding both yc and yp. c1 e power minus x plus c2 into e power minus 3x plus 1 by 8 into e power x. This is the first example. See the next example. Solve d square plus 4d plus 13 into y is equal to 2 into e power minus x. That is equal to given equation. So f of d into y is equal to q of x, where f of d is equal to d square plus 4d plus 13. Q of x is equal to 2 into e power minus x. First take the auxiliary equation. M square plus 4m plus 13 is equal to 0. Take the roots. Minus 1 plus or minus 3i. This is a plus or minus ib form and complex roots. So yc is equal to complementary function e power minus x into c1 cos 3x plus c2 sin 3x. Now finding the particular integral yp is equal to 1 by f of d into q of x. That is equal to 1 by f of d is equal to d square plus 4d plus 13 into 2 into e power minus x. So that is equal to 2 is the constant right outside in front of the f of d. 1 by d square plus 4d plus 13, the factorization is the complex roots here. Now replacing d by a is equal to here minus 1. D plus low minus 1 replacing, that is equal to 2 into 1 by minus 1 square plus 4 into minus 1 plus 13 into e power minus x. Simplification is 2 into 1 by 10 e power minus x. That is equal to 1 by 5 into e power minus x. So this is the required yp. Therefore general solution is yc plus yp. That is equal to y is equal to e power minus x into c1 cos 3x plus c2 sin 3x plus 1 by 5 into e power minus x. Okay. See the next example here. Solve d cube y by dx cube minus 5 into d square y by dx square plus 8 into dy by dx minus 4y is equal to e power 2x. So that is equal to operator form. F of d into y is equal to q of x, where f of d is equal to d cube minus 5d square plus 8d minus 4. Q of x is equal to e power 2x. So take the auxiliary equation. So that is equal to finding the roots here. M minus 1 into m minus 2 whole square is equal to 0. M is equal to roots 1 comma 2 comma 2. So one root is the distinct, two roots are equal. Therefore complementary function is yc is equal to c1 into e power x plus c2 plus c3x e power 2x. Now finding the particular integral, yp is equal to, that is 1 by f of d, d cube minus 5d square plus 8d minus 4 into e power 2x. Okay, 1 by f of d can write product of the factors, that is equal to 1 by d minus 1 into d minus 2 whole square into e power 2x. So which form here? E power ax here. A is equal to 2 here. D plus low 2 replacing. That is equal to here. We observe 2 is the root repeated 2 times. So in first factor d minus 1, okay, is non-zero. But second factor d minus 2 whole square, when d is equal to replacing 0 only, and the denominator 0. So 2 is how many time repeated? D minus 2 whole square 2 time repeated. Okay, 2 is the 0 root 2 times. That is equal to here. The special case here 1 by, this is non-zero, 2 minus 1. So d minus 2 whole square 2 times 0 square, what is formula? X square by 2 factorial. Formula in the k is repeated k times x power k by k factorial కదా. So here 2 times repeated, that is x square by 2 factorial into e power 2x, that is equal to x square by 2 into e power 2x. So therefore general solution is yc plus yp, adding both. So that is c1 e power x plus c2 plus c3x e power 2x plus x square by into e power 2x. Okay. See the next example. So solve dq plus 1 into x is equal to 3 plus 5 into e power t by 2. Okay, dependent variable is x, independent variable t and the solution is x is equal to in terms of t, that is equal to f of d into x is equal to q of t, where f of d is equal to dq plus 1, q of t is equal to 3 plus 5 into e power t by 2. So that is equal to auxiliary equation mq plus 1 is equal to 0. M is equal to the roots or one root is minus 1, remaining roots 1 by 2 plus or minus I root 3 by 2. Okay. So complementary function is, first is the real and distinct, c1 into e power minus t plus c2 in e power at kada, and 1 by 2 tt, c2 into cos root 3 by 2 t plus c3 into sin root 3 by 2 t. This is a complementary function. Next to yp, particular integral xp is equal to 1 by f of d into q of t, that is equal to 1 by dq plus 1, q of t is equal to 3 plus 5 into e power t by 2. Okay na. So here sum of the two functions here. So separating operator, so 3 is a constant, 3 into 1 by dq plus 1, and 3 into 1 kada, 3 is a common, 1 place lo we can write e power 0t. The 1 మనకి ఫామ్లో e power ax కదా, that is converted, 1 is can be write e power 0t plus 5 into 1 by dq plus 1 into e power t by 2. So that is equal to, here a is equal 0 first term, second term లో a is equal 1 by 2. So d place లో 0 replacing, 3 into 1 by 0 plus 1 e power 0t plus, ఇక సెకండ్ కేసులో d place లో 1 by 2 replacing, 5 into 1 by 2 whole cube plus 1 into e power t by 2, that is equal simplification, 3 plus 40 by 9 into e power t by 2. This is a particular integral. Therefore general solution is x is equal to xc plus xp, c1 e power minus t plus c e power t by 2 into c2 cos root 3 by 2 t plus c3 sin root 3 by 2 t plus 3 plus 40 by 9 into e power t by 2. This is the solution. Next one, solve dq plus 2d square plus d into y is equal to sin hx. So that is equal to given equation. This is the factors, d into d plus 1 whole square into y is equal to sin x, where f of d into y is equal to q of x. This is f of d, this is q of x is equal to sin x. So take the auxiliary equation, m into m plus 1 whole square is equal to 0, m is equal to 0 minus 1 minus 1. This is the 3 roots. 0, 1 is a single, minus 1 minus 2 equal roots. So that is equal to c1 into e power 0x into 1. c1 plus c2 into this equal roots, c1 plus c2 plus c3x into e power minus x. So next finding yp, yp is equal 1 by f of d into q of x, that is 1 by f of d is equal d into d plus 1 whole square sin hx. Observe చేయండి, do observe here sin hx. Sin hx is the hyperbolic function. So hyperbolic function can be write e power x minus e power minus x by 2 కదా. So here again sum of the two functions, the separating operator 1 by 2 common, this is the 1 by 2 common, 1 by d into d plus 1 whole square into e power x minus 1 by d into d plus 1 whole square into e power minus x. the sum of the two functions here, the two cases here. The first one is e power ax and a is equal to 1. The second case a is equal to minus 1. First place lo d place lo 1, second case lo d is equal to minus 1 replacing. That is equal to here. First one 1 by 1 into 1 plus 1 whole square e power x minus, but here d is a non-zero, d is equal to minus 1, but here second case d plus 1 whole square is that d is equal to minus 1 means minus 1 plus 1 0. So denominator 0 and how many times 0 is minus 1 is a root 2 times. So that is equal to 1 by 1 minus 1 into 2 times 0 is x square by 2 factorial into e power minus x. So that is equal to simplification is 1 by 2 into 1 by 4 e power x plus x square by 2 into e power minus x. That is equal to, therefore yp is equal to 1 by 2 common, that is 1 by 4 common, 1 by 8 into e power x plus 2x square e power minus x. Therefore general solution is yc plus yp, that is equal to y is equal to c1 plus c2 plus c3x into e power minus x into 1 by 8 into e power x plus 2x square e power minus x. So this is a solution. So next example. Okay, thank you. This is the type 1. When q of x is equal to e power x, then finding yp. For more videos, please do subscribe my channel, like and share it. Thank you.